Right, welcome back to the exciting world of acid-base equilibria. This will be part 8 for Mr. Newton's AP Chem class, and we're looking at weak acid and base calculations and all different sorts of stuff associated with that. So this one right here is the idea of percent ionization. Really easy. If you ever get these questions, rejoice. Simple, easy to solve. So what it's asking you is, if I have a 0.160 molar solution of, this right here is bromoacetic acid, and it's 10.7% ionized, what concentrations of products will that give me? Well, if it's 10.7% ionized, what they're telling you is that 10.7% of this initial amount became ions. So then that means that all the ions, and here's the reaction I've written out for you right here. So this is going to produce these two ions. So the original 0.160 molar here, 10.7% of that is going to become this one and this one. So what does that mean? Well, it's pretty simple. So if we were to look at the hydronium ion concentration, well, it's going to be 10.7% of 0.160, which turns out to be, you just take times 0.107. Let me punch that in my calculator right now. 0.17 molar concentration. There's that. And we can figure out the rest of them as well. So if we were to look at the bromoacetate ion, so here's the bromoacetate, CO negative. What's that going to equal? Well, it's going to be the same as this, right? Because these multiply by each other, so x times x. So it's a 1-to-1 ratio, so there we go. So we've got that. Now what about this one? Well, the original bromoacetic acid simply lost 10.7%. So you subtract the 10.7% from it. So that's going to give us 0.160 minus, so 0.160 minus 0.017. So our final answer for that one is going to be 0.143 molar. So these percent ionization ones are really quite easy. Here's another one that is probably a little bit more difficult. So let's look at this one real quick. What is the percent ionization of, in this case we've got chromic acid. So chromic acid, what if we started with an initial concentration of 0.270 molar at 25 degrees. So they want to know what the percent ionization is going to be. They don't actually just run out and tell you the percent, which we had in the last one, which made it really easy. Well, if we look up the Ka of hydrobromic acid, or not bromic, this is chromic acid, sorry. If we look up the Ka here of this ion, it's 3.0 times 10 to the negative 7th. We learned in our previous video that the Ka of a weak acid, if we're to break this up, is going to be x squared divided by I when you have a 1-to-1-to-1 ratio like this. So you can go ahead and draw out the chemical reaction if you need to make sure that that is the case. And we also said that on the bottom we can just use I as long as that Ka times 100 is less than the initial. And so 3.0 times 100 is nowhere near this. And so we're good. So then we can just plug our numbers in here and solve for x in this case, because we want to figure out how much of this came out. And then once we know how much of this came out, we can figure out what percentage of the original amount was put in is that. So 3.07 is our Ka. 3.0 times 10 to the negative 7th, sorry. And that equals x squared divided by 0.270. So multiply by 0.270. And we get this. So x equals 2.85 times 10 to the negative 4. So that's the actual amount ionized. We're still not at a percent yet, but we know exactly how much ionized. We know exactly how much we started with. So to find the percent, this is how much we got out of the total. So we'll take and divide the amount ionized by the initial amount. Just a simple sort of percent situation. Just like if you got 45 out of 48 on your test, you divide the amount you earned by the total amount you could get. So so then our percent ends up, or our answer to this is 0.0015, which translated to a percent. I rounded that off to 0.11%. So we multiply times 100 and turn it into a percent. So there you go. So that is the percent ionization of this. Look up the Ka, run our Ka factor from our ICE table that we just turned into an easily usable equation. Make sure everything is right and the situation works. Figure out our amount ionized and divide it by our initial amount. And there you go. You can figure out percent ionization really fast and really easy.